Okay, so welcome back to another day of polynomials and quadratics. This is the final day that I'm going to post, but I will put up some optional other, at least notes and that sort of thing. So if you wanted to look at them either during the summer or even next school year to kind of refresh or just look over as you're learning about quadratic functions, then that would be fine, and hopefully that will help. Certainly if you're ending up skipping 9th grade math and moving to 10th grade math, some of this might help in the future. So today is the 8th, but I'm going to put this on the 9th. So today what we're going to look at, is quite a bit, so don't worry if when you watch this you don't fully, you're not fully comfortable with all of it. The cat. That's not really a big concern, as this is not a required unit in 8th grade math. So, quadratic functions. Okay, so specifically we're going to be doing terms and representations, meaning tables, graphs, and equations. Okay, so general idea of a quadratic function is that it is a polynomial of degree 2. Okay, and the general form of that, let's switch colors here. So the general form is f of x equals ax squared plus bx plus c. And, or you could say, if you wanted, y equals ax squared plus bx plus c. Okay? And a, b, and c are constants in this formula. Okay, so that's the general form of a quadratic equation. So also, the important thing to know about quadratic functions they have U-shaped graphs. And these are called parabolas, or parabolas. Some people say parabolas. I prefer parabolas because I feel like I would spell it with a W if I call it parabolas. So parabola literally is just a U-shaped graph. Okay. Now, some different things about quadratic functions is quadratic functions are symmetric. In other words, one side is the mirror image of the other. And they are symmetric over what's called the line or axis of symmetry. Okay, now I'll show you all these things when I show you kind of a general graph. Okay, and so that kind of would be another word that you would need to know. So they're symmetric over that line or axis of symmetry. And then also in quadratics, they have a highest point, which would be called the maximum, or a lowest point, which would be called the minimum. Either way, whether it's a maximum or a minimum, this point is called the vertex of the parabola. Okay. And the last thing to kind of mention is that the y values in a table of a quadratic, will repeat as mirror images, except that vertex. Okay, so now on the next page, I'm just going to kind of show you some very general quadratic graphs, and kind of the two simplest types I can do where there isn't, basically B and C are both 0. So some examples, and since I'm not using grid paper, these aren't maybe going to be the best examples. So here are some examples of quadratic graphs. So this is f of x equals x squared, or just y equals x squared if you want to write it that way. Okay, so one way to find the points is that you could plug in the x values. So I'm going to do that on this one. So find the y by plugging in x. Okay, so I'm going to go from -3 all the way up to 3 on the x. And then to find the y, or f of x, either way, I'm going to plug that in. So we said f of x or y equals x squared, so -3 squared is 9, so it would be -3/9. Okay, and I'm going to do that same thing. This is one option for finding points in a quadratic graph, or just finding points in the table or anywhere else, so the points of the quadratic. -2 squared is 4. Okay, -1 squared is 1. 0 squared is, of course, 0. Okay, and then 1 squared is also 1. And you'll notice 2 squared is, 2 squared is 4. And 3 squared is 9. And you'll notice how here, this is that vertex, and then these points are mirror images of each other. And you'll notice, so this, therefore, is the vertex where everything else is a mirror image across it. Okay, so I'm just going to kind of generally sketch this. And then later I'm going to show you how to do quadratics that are a little more tricky than this one. So what I find really useful is I just start with the vertex, and then I'll go kind of over. -1 was 1, and I'm sorry, -1 was 1, and 1 was 1. And then 2, 3, 4, okay, and then up to 3 on both sides, which is 5, 6, 7, 8, 9, way up here, so over here, and over here, and hopefully I can draw kind of a U with that in the best way possible. Not perfect, but not terrible. Okay, until that very end. So here, let's kind of go like that. All right, so then this is that parabola. That graph is called a parabola. And then you'll notice this is the vertex. And kind of this imaginary line down the middle. And often it's drawn as a dashed line. This is what's called the axis of symmetry. Because you'll notice that all of the spots on one side are mirror images on the other. For the most part, my drawing wasn't the best at the top there. Okay, so there you have that axis of symmetry and the vertex here, which is, in this case, a minimum, because it's the lowest point at 0. Okay, so you kind of see all those points. Okay, now I'm going to do a kind of second example, which, again, it's a relatively simple one. In this case, I'm going to do -x squared. Okay, or y equals -x squared. Okay, so again, I'm going to, in this case, plug in points to find y. Okay, so I'm again going to choose -3 up to 3, just because I know that happens to be, whoops, sorry about that. It happens to be a little easier. So if I were to do a -3 squared, I'm actually going to get a -9. Okay, a negative, -2 squared, which would give me a -4. And negative, so this is -9, -4. -1 squared, which would give me -1. -0 squared doesn't matter, it's still 0. Doesn't matter that that one was negative. Okay, and then -1 squared, which is then again still that -1 because the negative is not part of what gets squared. It's the coefficient in front of the x. It's not the x. Okay, so -1, and then you're going to notice that this is also going to be symmetric, but across that 0. Now it's not always 0, but the ones we're doing right now are. So -3 squared would be -9. Okay, so in this case, we're kind of going to do the same thing. But on this one, that 0, 0 is still that vertex. But in this case, this one's going to be pointing kind of downward. So positive and negative ones both go down to -1. Okay, the 2's go down to 1, 2, 3, 4. So right here and here. And if I went over to 3, it goes down all the way 5, 6, 7, 8, 9. Okay, so and then this graph is going to kind of look more like a downward facing U. Okay, in fact, they're called opening up and opening down. Okay, so that one kind of opens down, but you'll notice again, it's symmetric across this axis of symmetry in the middle here. So this is that axis of symmetry. Okay, and then here, this vertex, in this case, it would be a maximum, and it happens to occur also at 0, 0. Okay, now really quickly, I'm just going to kind of show you some other points you might need to be aware of depending on the type of quadratic graph that you're looking at, but I'm not going to actually give an equation for this one. I'm just going to show you some other points. So, for example, it may be that it doesn't cross at 0, 0, so that your parabola looks something like this. Okay, and in this case, these here would be x-intercepts. Eventually, this would cross that y-axis. So up here somewhere, you would have a y-intercept. Okay, way up here somewhere. Didn't really draw that so great. And down here is again that vertex. Okay, and these x-intercepts can be called roots as well, or zeros sometimes. Okay, so there can be x and y intercepts in quadratic graphs. So I'm going to do now a couple of examples of graphing a quadratic where we aren't plugging in points, or at least we aren't plugging in every point. Graphing factorable quadratics specifically. So here we're going to do graphing factorable quadratics without plugging in points. Okay, so how are we going to do this? Well, there's some steps. Now, of course, you could always plug in points, but if you don't necessarily know where the vertex is and what points you're supposed to be using, then this can be a way if it's a factorable quadratic. So basically, here are the steps for doing this. The first thing you do is you factor the quadratic. Okay, and then so this is the first step, then you find what's called the roots or zeros, the x-intercepts. Okay. And this is where the graph will cross the x-axis. Okay, you then note the y-intercept. Okay, and this specifically will be the c value in the equation, in the expanded form. Okay, then you find the axis or line of symmetry. And this will be the number between the two roots. Whoops, sorry. Oh, you can't see that. I apologize. This will be the number between the two roots, or the two x-intercepts. Or you can probably, this equation, the equation is negative b over 2a, which this is the equation for the axis of symmetry. Okay, and then the last thing is you're going to find the vertex by plugging in the axis of symmetry. And you're going to plug that into the equation. Okay, so I'm going to show you a couple of examples of doing this. This is really kind of two lessons in one, so if this is concerning or confusing, you can kind of just do some of the questions that just relate to the original part, or you can pay attention to all of this. Again, these are things that will really help you next year, and therefore aren't absolutely key to being comfortable with this year. So don't be too concerned if you're not fully comfortable and, just kind of watching this is pretty good enough. All right, so let me give you one example. I'm going to do two examples of this. They're both going to be ones that quadratics that open up as a U shape. Okay, so the first example is f of x equals x squared minus 2x minus 3. Now I want to note that this number in front of this is technically a 1, so your a is 1, your b in this case is negative 2, and your c is negative 3. Okay, so just kind of noting that. Okay, the first step, remember, is to find the factored form of this. So in this case, that f of x equals, and this will be the factored form. Okay, I need two numbers that multiply to a negative 3 and add to negative 2. Okay, those numbers are negative 3 and positive 1, because negative 3 times 1 is negative 3, and negative 3 plus 1 is that negative 2, that b. Okay, now when you're finding the x-intercepts, you're trying to find where y is 0, because if you're looking at the x-intercepts, y has to be 0, because that's where it crosses the x-axis, and therefore y is 0 there. Okay, so what I'm going to do is say 0 equals that x minus 3 and that x plus 1. Okay, now if we note right over here, and I'll kind of do this in a different color here, if two things multiply, so two factors multiply to 0, one of them must be 0. Okay, so either you have x minus 3 is 0. Okay, so there's two options here. There's going to be two solutions to this. Or you have x plus 1 is 0. Okay, now for x minus 3 to be 0, of course, just x is just 3, because 3 minus 3 is 0. Okay, and for x plus 1, to be 0, x has to be negative 1, because negative 1 plus 1 is 0. Okay, so there's your two x-intercepts. So the roots, or the zeros, are are 3 and negative 1. Okay? So now, I like to personally, actually like to, at this point, kind of start graphing this. Sorry, and this is not going to be the most perfect graph in the world, but kind of here we are with that. Okay, so I'm going to go over 1, 2, 3. So here's my positive 3, and here's my negative 1. So far I know that those 2 points are there. And then I'm going to look at kind of what's in the center. And this was kind of step 2 already kind of here. And then as we go to step 3 to find the y-intercept as well, before we find the axis of symmetry, the y-intercept is this c value, that -3, because if I were to plug in 0, 0 squared is 0, minus 2 times 0, which is also 0, so I would be left with -3. So the y-intercept is -3. So I have another point here, 1, 2, 3. So I know that my parabola kind of goes like this. Okay, now my next step is to find the line or axis of symmetry. Okay, and in between, so right between 3 and -1, it's kind of like finding the average of the two, to be honest. Okay, so it's 2 over 2, which is just 1. Or you could have used that -b over 2a, which is that the equation for the axis of symmetry, or well, x equals -b over 2a. And -b in this case was a -2 over 2 times 1, which is 2 over 2, which again is 1. Okay, so that equation, so that's the line of symmetry. So there's kind of like an imaginary, and we kind of draw it with dashes across that spot. So everything on this parabola is going to be symmetric over that line. And the last step is to plug in that x equal value into the equation. I tend to plug it in to the factored form. It is completely up to you, but so I'm going to take x minus 3. So I know it's 1 minus 3, and then times 1 plus 1. And again, you could plug it into the expanded form. That would be fine. 1 minus 3 is -2. 1 plus 1, so this is f of x equals, or y equals, okay? -2 times 2, which is -4. So I know now that my point for the vertex is at 1, -4. Okay? So I would go 1, and I would go down to here, -4, and kind of draw my parabola that way. Okay? Of course, because it's on paper, it's not perfect, but that's kind of the idea. Okay, I'll do one more example. Like I said, this is more like 2 sections of notes, so if you just want to pay attention, like watch this, that's fine. If you also want to actually do IXL problems, that's fine. But this is kind of, getting you a unit that didn't exist and probably wouldn't have otherwise. All right, so let me do one more example. And again, these are all factorable, so they're a little bit simpler. So example 2, okay, is in this case, I'm going to do f of x equals x squared plus 6x plus 8, or if you want to think of it as y equals x squared plus 6x plus 8. Okay, so first step is to factor that. So I have f of x, and in this case, I need 2 numbers that multiply to 8 and add to 6. So those numbers are 4 and 2, because 4 times 2 is 8, and 4 plus 2 is 6. Okay, so that's the factored form. And then my second step is I'm going to set that equal to 0. So 0 equals x plus 4, x plus 2. Okay, and remember, if the 2 factors, this times this has to equal 0, one of them has to be 0. So either I have x plus 4 is 0, or I'm going to have x plus 2 is 0. Okay, so in this case, -4 plus 4 is 0, so x would be -4. Or, in this case, x would be -2. Okay, so my 2 x-intercepts are -4 and -2. If you want to think of them as actual coordinates, which they are, it's -4, 0, and -2, 0. Okay? Okay, and again, I like to kind of graph this at this point, and again, I would probably use grid paper if I were going to actually graph this, but obviously that's not exactly available right now. So, all right, so in this case, -4 and -2. So what I'm going to do is go down 1, 2, 3, 4, and my 2 intercepts are those 2 spots there. Okay, at -4, 0, and -2, 0. All right, then my next step would be to find the y-intercept, which remember is your c value And in this case, if I go back up to my equation, I didn't write my A, B, and C. My A value is 1 because there's a 1 there. My B value in this case is 6. So this is A, this is B. Oh, copper now. And, and C is 8. Sorry, the cat just kind of joined me there so you couldn't see it. Okay, so in this case, the y-intercept is 8. So, and the actual coordinate will be 0, 8, because it's the y-intercept, so an x is 0. And again, if you look up 0 squared plus 6 times 0, those are both 0, that would be 8. So, as I draw my graph, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then what the next thing I'll do is find my line of symmetry, or my axis of symmetry. Okay, and again, I can either kind of just take the average of those two numbers, so negative 4 plus negative 2 over 2, which would be negative 3, or I could use the formula x equals negative b over 2a, okay, and then I could plug in the negative b, which would be negative 6 over 2, and in this case, all of our a's, because we've only been graphing ones that have a values of 1, so that would also be negative 3. Okay, so my axis of symmetry is right through here. Okay, so I'm kind of just drawing a line that's kind of right down the center there. Okay, and then the last thing to do is to find the vertex. And again, you're going to plug it in, and I prefer, like I said, to plug into this factored form. So f of x in this case would be x plus 4 times x plus 2, and I would plug in that negative 3. So negative 3 plus 4 and negative 3 plus 2. Negative 3 plus 4 is 1, and negative 3, plus 2 is negative 1. So I have a minimum here, and the vertex is at x is negative 3, and y is negative 1. Okay? So that minimum is at negative 3, negative 1, so kind of right here. And then I'm going to do my best to kind of draw a parabola that hits that spot and hits that spot. Okay. This is kind of more sketching parabolas than really fully graphing. All right, so that's the end of that, really kind of more two sets of conceptual ideas. I am going to, at some point, post some other things on quadratics, like the quadratic formula and things like that. But hopefully we will have kind of a plan moving forward for specific 8th grade math work. And so that will be hopefully starting next week. Have a wonderful day.